So thanks, Meryl. I feel like I'm the elder of this conference with all these young, brilliant researchers. This is actually my second appearance at Social Bridges. So the first time was in 2020 during the pandemic, and Meryl was something of a one-woman show. She did the intros for all the speakers. She also was the main discussant, so she led all the questions for the speakers. So I'm really happy to see that there's partly a live component to this one, and that there are actually people in the room. It's really nice. I wish I could be with you guys. So my talk, this is going to be more a talk about evolution. So it's called Move Not Groove: Why Dance is a Better Way Than Music to Think About the Origins of Rhythmic Entrainment in Humans. And so since the last Social Bridges, I've published a book with Oxford called The Unification of the Arts, a framework for understanding what the arts share and why. The book covers all of the arts, but I want to just focus your attention on this part of the book, these arts of interpersonal coordination, what I call the coordinative arts. And so if you look at the chapter titles, it kind of reflects my take on the distinction between dance and music. That dance is about the coordination of bodies, and music is about the coordination of voices. But I think from a functional standpoint, they're really quite equivalent, or evolutionarily quite equivalent, but they work in different domains. So to me, dance is to the body what music is to the voice, or to surrogates of the voice like instruments. And so this coordination occurs in very different spaces. So the coordination of group dancing occurs in physical space, whereas the coordination of chorusing instruments occurs in a kind of a weird virtual space that we call tonal pitch space. So the spaces of coordination are quite different. But I think when it comes to rhythm, we're talking about exactly the same system. So if you think about the concepts that apply to rhythm in dance and music, they're pretty much exactly the same thing. So we talk about the timing of events, we talk about duration values, tempo, metrical structure based on different accent patterns, motives, expressive timing, interpersonal entrainment. I can't think of any concept of rhythm that applies uniquely to dance or to music. I think it's really a shared system behaviorally and neurally, which will be a central point of this talk. I do want to make mention of one further difference before I go on. And actually, I think Konstantina kind of previewed this idea very nicely, that when it comes to the learning mechanisms, there really are two, I think, very different systems. And so one is the system for vocal imitation that Konstantin and other people think is directly related to body entrainment. I take a different view, and she and I are good friends, and we love to have this debate among ourselves. But I think that the other imitative system that humans have, which is that of gestural imitation, is going to be much more central to the origins of rhythmic entrainment. But this is the kind of debate that we're having, and I think it's a very exciting kind of debate to have, whether this imitative system for the voice is really the key link to body entrainment, or whether something about gesture. So I really like debating this point with Konstantina, and I think it's great for our field to have this kind of debate. So when I spoke, so it was really nice to hear Suzanne's talk and some mention of speech and conversation. So my last talk in 2020 was called The Two Roads to Creating Social Cohesion. These two different systems, one of which I'll talk about today, one of which I won't. So this one's going to be about the interpersonal entrainment, motoric entrainment. But then we have this other system, which is forming social bonds through conversation. And so I developed this, what I call dual cohesion model, that humans have two very different systems for forming social bonds, and the prototypes would be dance and conversation. And so they work in very different ways. And so my talk today will be about dance. Dance is the system in which we coordinate through synchronization. We've heard a lot about synchronization at this conference, whereas conversation is the way we coordinate through alternation. So occasionally we speak at the same time, but it's not very common. Basically, conversation is our coordination system that works through an alternation of parts, compared to things like dancing and chorusing, which work with synchronization of parts. As a result, the rhythms are quite different. And so dance and chorusing take advantage of metrical rhythms because they permit predictability, whereas the rhythm of conversation is far more non-metric. So again, for the rest of the talk, I'm going to focus on this system, but we could maybe have another social bridges about conversational interaction in relation to forming social bridges. So I think there's not a very strong representation of music cognition. I think that most people here are coming from the dance side, but I do come in large part from the music side. And so I want to make this contrast between what's called groove in music cognition and what we're talking about at this conference, which is about movement and about dance. And so a lot of the ideas that are being presented in this talk were published in a theoretical paper called Group Dancing as the Evolutionary Origin of Rhythmic Entrainment in Humans from 2020, I'm not that old, from 2022. The accepted models of rhythmic entrainment in humans are completely asocial, and we got a taste of this in the video of the cockatoo snowball, which I'm going to show for the second time today. So all these models about the origins of entrainment place the origins in music. That music came first, that music provided the rhythm for dance. And then one day, some, ancient hominids sort of felt the groove, felt the beat, and decided to move as a secondary evolution. So this definition may be a little bit vulgar to people who work in dance, but this is a very common definition of dance from the standpoint of music cognition. What is dance? Dance is music-induced movement, okay? So again, this is not the definition, I think, of most people attending this conference, but this is a very common definition that, first there's music. Music has a certain intrinsic feature that makes us want to move, and that's called groove. And so people in music cognition don't study movement, they study this inclination to move. So if you listen to a certain kind of music, you want to, tap your finger, tap your foot. You're not dancing, but you're doing something, some kind of music-induced movement. So the view is that music is the primary driver of rhythm, of rhythmic entrainment. Dance is this derivative. Dance comes from this music-induced movement that dance, music has this intrinsic feature of groove, and then that makes you want to then, as a result, dance. And I want to take a very different view of the origins of rhythm than this music first model. So this has been shown already within the last hour by Konstantina, but this is a sulfur-crested cockatoo called Snowball, who has a very spectacular ability to dance to music. I'm going to show this video. Okay, so this is a really spectacular example of dance in a non-human animal. This animal, like cockatoos and other birds like this, show this amazing capacity to entrain to a rhythmic acoustic beat, as we saw with Snowball. But it does beg the question of who's functioning as the Backstreet Boys in cockatoo culture. In other words, who is generating this rhythmic acoustic beat that the animals clearly are able to dance to? And to the best of our knowledge, when it comes to cockatoos, the answer either is that it's nobody, or we simply don't know enough about their ecology to know the answer. So this dancing animal model actually raises more questions than it answers. But basically, in terms of human evolution, leads to this kind of two-step model that first there was music, that first music evolved. Music provided the beat, this acoustic stimulus for movement. And then secondarily, like I said, maybe one day, this ancient hominin kind of felt the beat, felt the groove, and then decided to dance to it. So the contemporary model is very much a two-step evolution in which music comes first, music provides the beat, and then as a secondary evolution, we acquired the ability to entrain our body movements to these regular acoustic beats. And so I call this in the paper the music first model, that the source of this entrainment signal comes from, in quotes, musicians. Musicians, in some matter, either vocally or instrumentally, generate this beat. This serves as the entrainment signal for then a second population, a second evolution, to develop the ability to then entrain our movements to these patterns. So again, this music first model is very much a two-step, a two-stage evolution. The music provided the beat, and then as a second evolutionary step, we evolve the capacity to then entrain our body movements. And so I want to think about this in a very different way that does not prioritize music. And so I think Giacomo's talk yesterday made a very good introduction to this idea that there are really two basic forms of entrainment. You can entrain to a signal which is external to you, like a drum beat or MP3 file, like orchestra, whatever. But you can also entrain to one another. And when you dance, say a typical partner dance like a tango, both things are happening at the same time. And so I think Giacomo did a really nice job talking about the music as being external versus the visual cues that are more mutual. And so I want to think about a model that sort of replaces this external signal and makes everything into something mutual. And so this is very much an interpersonal theory of the origins of rhythm. It doesn't require something external to the people who are doing the entrainment. So I want to get beyond this groove model and think about that the origins of rhythm come from actual dance movement and not there was music first and then we decided to move to it. So I want to make this kind of move, not groove model of the origins of entrainment. So here's a very different take on this, a very different animal model. And I want to turn off the audio. This is actually just a cell phone video from a family. This is a zoo in Atlanta. These are two captive chimpanzees. And the title of the video is, two chimpanzees walking in a conga line. And you'll see this is a very synchronized, very entrained, two chimpanzees walking in lockstep. But I want to turn off the audio just because it's very silly sounding. So these two female chimpanzees, they engage in this activity multiple times a day. I'm going to stop this for a second. I want to point out one really key thing about this ability is that if you look that the back animal has her left arm. There's actually haptic contact between the two animals, as shown here. They're going to sit around for a while, so I'm going to advance this a little more to when they get back into their conga line. So you can see that they're walking. They're going to be walking in lockstep. They're synchronized, essentially like a conga line. And you see that the back animal's left arm is making haptic contact with the front animal, which I think is really critical for this synchrony. Okay, so this was actually analyzed quantitatively by Lamera and colleagues in this paper, coupled whole body rhythmic entrainment between two chimpanzees. And they verified that just kind of what you see that this movement is very synchronized. These animals are walking in lockstep, and there's a very high degree of synchrony between the two animals. So take note, in this example, there's no music, there's nothing external, there's no drum beat, there's nothing external to these animals that's driving their synchrony. Instead, we find a very significant cue. We find physical coupling. There's haptic contact between the two animals. There's visual contact. It's a bit asymmetric. The back animal can see the front animal and not the reverse. And I think what's going to be sort of one of my speculations here is that bipedalism is going to be a really critical factor in the evolution of dance, but also of just rhythmic entrainment in general. So if you look at this, they're not walking on their knuckles, the two animals, they're walking in the bipedal stance that chimpanzees have, the ability to engage in. So it's a very different view that, first there's music and then entrainment occurs. Here it's all based on mutual entrainment using physical haptic cues, visual coupling. And I think the bipedal stance is going to be really important for this as well. So I'm going to take you to another primate aside from chimpanzees. So there's a famous archaeological site, maybe you've heard of, called Laetoli. It's found in the north of Tanzania near the Ngorongoro area. And so the archaeology group of Mary Leakey in the 1970s discovered a bunch of footprints that were attributed to an ancient hominin that lived there. So Australopithecus afarensis lived in that part of Tanzania 3.6 million years ago. And so these are referred to as the Laetoli footprints. And so they've been very studied over the last 50 years. And so the most famous site is the G site. And so there's evidence of minimally to perhaps a third organism. that was walking, they were walking side by side. And all the evidence is that they're walking very closely together and potentially they were walking in lockstep with one another. So people have analyzed so this is thought to be a male and a female walking very close, that the distance between their centers of mass is only 1 foot. Imagine how close you have to be with another person walking side by side to have only 1 foot between your belly and their belly. And so all the evidence is that this, probably a male, female, were walking in lockstep or walking very closely to one another. And so when it came time to make a diorama of this at the American Museum of Natural History, they made this where the male's arm is around the female's shoulder. You know, there are many different ways of doing this representation, but Ian Tattersall, who was the curator of this diorama, said the trails are so close together that the hominids must have been in some kind of physical contact when they made them. And I don't know much about archaeology or about the methods here, but for me, for these organisms to be in lockstep, there had to have been this kind of physical contact. And so I don't know exactly what it looked like if it was this, but there had to have been this kind of haptic interaction for this synchrony to occur for these organisms to be essentially in lockstep. So this led me, so in this paper that I published in 2022, to propose an alternative model to this groove model, this group dancing model, saying that instead of having this external signal, that the interacting organisms were both the source of the rhythm and the effector, and that all the entrainment evolved through mutual entrainment, not some kind of snowball kind of thing where there, first there was music and then there was movement. That here the interacting organisms were both the source of the rhythm and the effector of entrainment. I'm going to call this the group dancing model of rhythmic entrainment. And so this is very much an interpersonal model. You don't have to have some distant drum beat or some other organism like a human playing for a cockatoo. This is very much about you and me synchronizing our movements with one another. And again, I can't validate this idea, but I really support the idea that the origins of dance, the origins of rhythm really come from the evolution of bipedalism. So this is very much a locomotor model, very different than other kinds of models about the origins of the rhythm, like this vocal model that's been alluded to earlier. I think one distinct advantage of this model over the other model is that it allows for multiple sensory cues to be involved in the evolution of entrainment. And so one kind of cue is acoustic. So this doesn't have to be music. This could simply be, I'm going to talk a lot about body percussion, the sounds that we make when we move. Visual cues are very important. And so for a long time, it was said in the music cognition literature that there was a natural advantage for acoustic cues when it came to entrainment. The visual cues were inferior. So if you had just like a flash of light, people were less synchronized with a visual stimulus than with sound. And this all changed when people started to look at now moving visual patterns as opposed to static things. So if there was a moving ball, bouncing ball, whatever, people then were as good at entraining to a moving visual target as to something acoustic. And so that's going to be the case definitely when we talk about the evolution of dance. It's not going to be a static, a tree. It's going to be some other person who's moving along with you. So it's going to be a moving visual image. And as I mentioned, I think haptic contact is really critical for this kind of evolution. So I'm not a contemporary dancer like a lot of the people at this conference, but I mean, 2 nights ago, Sunday night, I went to do blues dancing at a dive bar here in Toronto. And as Giacomo alluded to, I mean, the acoustic cue was definitely external to us. We were listening to blues music. But the extent to which there was visual contact varied quite a bit because there are different kinds of contacts with the partner. So in the extreme, you're very far apart, like arms distance from your partner. But when I would dance the what's called closed embrace, I'm basically chest to chest with my partner, and I have no visual sense really of my partner. I rely completely on these kind of micro movements that come from our body contact, which become very salient when I'm dancing very close with a partner where I really can't see them. So I'm hearing the music, but I'm really feeling all this kind of micro movement coming from the core of my partner. But I want to go beyond simply sensory motor cues because I think it's very important to consider models about the evolution of culture. So I want to talk about just a general social imitation perspective. So it's thought that the fact that we have this really spectacular culture is based on the fact that we have a very sophisticated system for social learning, that we learn things from other people. And gestural imitation is a very important mechanism for not just imitating, but for learning from teachers how to perform all kinds of skills. And so this is a general concept within the study of human evolution, cultural evolution, that culture is predicated on our capacity to imitate, and especially to engage in gestural imitation. Merlin Donald talked about a stage in human evolution that he called mimetic culture, in which there were what he called group mimetic acts, similar to what I'm calling these acts of group dancing. And this provides a very different way of thinking about the functions of dance. We think about this as pleasure display, but coordination essentially is a kind of cue for conformity. It's a way of homogenizing us to make us be more similar and hence more different than the competing groups that are trying to potentially kill us. So I think about coordination not just as something for bonding, but as something that, like I said, a cue for homogenization of behavior to make us more similar as a culture, as a group, and hence make us more different, accentuate differences from other groups that are really an important driving force for the evolution of culture and of cooperation. So instead of thinking about music, I want to think about the acoustics as being in relation to body percussion. And so things like leggings and rattles, as far as I know, are universal. I've seen videos of dance from pretty much every part of the world. And so things like leggings and rattles are, as far as I can tell, universal features of human ritual culture. So I want to play an example of traditional Aztec dancing. I was a postdoc in San Antonio, Texas in early 2000s, and this is not my group, but I spent 4 years, full regalia, white guy dancing in a traditional Aztec group. And so I got a lot of my ideas about body percussion from doing this kind of Aztec dancing. And so you're going to see multiple kinds of body percussion here. A lot of the dancers are holding rattles. What you'll see in the video is that they also wear leggings called chachayotes that contain the seed of the ayayotl tree. You'll hear a sort of amount of vocal percussion through grunting as well. To be fair, there's an external signal here. There's a drummer. It kind of ruins my demonstration a little bit, but I want you to get a sense of the body percussion that comes from the dancers in terms of their rattles, in terms of their leggings, and their vocal percussion. So I'm going to start this. I'm going to move it ahead a little bit.
Stephen, I'm going to block you for 1 second to say that I think when you shared your screen, you may not have shared your sound. Would you like to try and see if you reshare your slides and click that silly little button that says...
Oh, I thought, okay, I did during the demo. And so...
I'm going to try again, just in case. Sometimes these things don't work, but we would so love to hear the sound.
Oh, so you missed Snow. Okay, I guess you knew Snowball from... Okay, yeah. No, I did it during the... Okay, sorry about that. You should have...
Holds. Let's see if it holds.
Yeah, it should help now. Oh, okay.
Let's try again.
That works? Oh, you sure told me earlier. Okay, so all you missed. So the one with the chimpanzees, I muted anyway, so there was nothing to miss. Snowball, I think you've seen Snowball before. Okay, again, traditional Aztec dancing, 3 kinds of body percussion: the leggings, the rattles, the vocalization. There's also going to be a drummer in the background. I'm gonna stop it there, but I just want to make a point about this before I go on that. So there is a drummer in the background who you're not seeing, and the drummer we're calling a musician, and the dancers who have this body percussion, we don't call them musicians, we call them dancers. But in reality, they're generating exactly the same acoustic rhythm pattern. So whether you're doing this with your hands with the drum or doing it through your leggings and rattle, you're generating exactly the same rhythmic pattern. But we call one person, okay, that's a musician. We call these people dancers, but it's really they're generating the same rhythm in the process. So I want to think about different sources, and so I'll distinguish here on the one hand body percussion that comes from the body surface itself versus things that are attached to the body. So when it comes to body percussion through the vocal tract, it doesn't have to be, melodies and songs. We heard things like grunting and screaming. So if you know, for example, the haka ritual of the Maori in New Zealand, they do a lot of grunting, so that generates body percussion. Things like necklaces can also add to that. When it comes to the body core, body beating, like we see with gorillas, and in many traditional cultures, we look at the First Nations of Canada. If you look at people add things to their regalia that will clank as they're moving. So as they're dancing, you hear all this percussion coming from their regalia. When it comes to the hands, we have things like clapping. I mentioned rattles are quite universal across cultures. Likewise, they're stomping with the feet and leggings. So many sources we don't need music. Music might help, but we don't need music to achieve a strong sense of acoustic stimulation that's generated from our movements. It's not external to us. It's generated from our body movements. So I think body percussion is really key to thinking about the origins of interpersonal rhythmic entrainment for group dancing. The most recent part of my theorizing about this comes from the realization that if you look at these implements that are used in these traditional cultures, they contain some form of beating of beads in these leggings and these rattles. And so I've developed a new concept that I call beating for beating. And so beads, as I've started to learn about, are actually very ancient in human culture. They go back potentially 150,000 years, almost to the origins of our species. And so this particular figure shows beads that are based on shells from mollusks. And so as you see, a lot of these have perforations. Some of them were thought to be natural perforations, but there's also evidence that humans bored holes in these shells in order to create perforations to allow for beading in the form of necklaces. And so you think, okay, necklaces, that's something recent, maybe the ancient Egyptians, but necklaces go back at least 80,000 years in human history. And so this idea of beading for beading, I kind of mentioned this, that beading goes back potentially to the origins of Homo sapiens, based on marine shells. I mentioned this thing about perforations. So when people talk about what are the functions of, using beads, makes very, sense that this is involved in ornamentation or displaying symbols of social status. But I want to speculate without much evidence, evolutionarily, that in addition to serving as a signal for ornamentation, that beads were used for potentially tens of thousands of years as body percussion for group dancing, as evidenced in contemporary times by this, I think, universal presence of things like rattles, leggings, and regalia. If you say to me, okay, what's the evidence? I don't have the evidence. People talk about this as being ornamentation, but I think it's equally likely that this kind of beading was used, just as we find in modern times, as forms of body percussion. So this idea, which is developing, I call beading for beading. So the last thing, I think I'll finish before time. The last thing is to kind of bring this into the lab. And so take this beyond evolution, but think about people actually interacting. And so we've done an experiment comparing these two different kinds of cues. And so the gold standard for external entrainment is, of course, a metronome beat or music. But we decided to look at the other kind of entrainment cue, a mutual entrainment cue, is by simply creating some body percussion by adding what are called foot tambourines. So I'm going to just show you what that looks like. So these are just added to the ball of the foot. And so when the dancers move, they creates a clanking sound. So this would be the mutual form of acoustic signal. So this is not like Giacomo's very sophisticated motion capture study. This is actually a very simple study, just using accelerometers. And so we use the cross correlation between the time series as a measure of the interpersonal synchrony. We look at this both in the vertical axis and in the side-to-side horizontal axis. I'll show you a video. There's no sagittal movement here, so we didn't quantify the sagittal axis, but we look at both vertical and then side-to-side horizontal movement. And in addition, we want to compare the efficacy of different sensory cues. So in all cues, the two members of the dyad, they're looking at each other, they're engaged in physical contact, the hands, and they're wearing these foot tambourines as body percussion. So that's for the all sensory cues. So look at the effect of haptic contact. We do the same thing, but don't hold hands. To look at the effect of visual cues, they held hands, but they were blindfolded. And then for the no audio, we took off their foot tambourines and we piped in white noise that would mask any kind of foot contact with the ground. So here's a video. I just want to point out that, compared to what we've seen with these professional dancers, these are first-year undergraduates. These are non-dancers. They've been taught this little sort of salsa-ish step 5 minutes before this. They just pick it up, So this is really a non-professional, untrained group of dancers. So here's what the task looks like. So I mentioned in one set of conditions, they're wearing these foot tambourines, and another they don't wear them, and they're hearing a metronome at the same tempo. So here are the results. So the y-axis is going to show the cross correlation, which will be the measure of synchrony, mutual versus external. I'll focus on the external first. That's kind of the gold standard of an entrainment to an external beat. The green bars will be for the vertical axis. The blue bars will be for the horizontal axis, all cues, whatever. Then the absence of the cues. So here are the results for the external entrainment to a metronome. The correlations, I think, are reasonable for non-dancers just having been taught this on the fly a few minutes before. One thing that's surprising here is that we see no really significant effect of the removal of cues. I'm going to talk on the next slide why I think the no haptic is not showing an effect. I've talked so much about haptics in this talk, and I'm showing really no effect of not having the handhold. But the big question for us is what happens when you get rid of this typical external cue and make all the cueing internal, mutual to the performers? Is there a big drop off in the entrainment? And I put the mean of so there are three conditions that are matched. The first three here, I put the means there. And the results are identical. There's no difference between using mutually generated acoustic cues versus this, I said, like gold standard of external cues. So again, these results are essentially identical. So the mutual cues are as effective as the external cues. The only effect that we saw that was significant here was that when we don't have audio, there's a big drop off in entrainment. So audio seems to be really important as a cue. But how come the haptic is not important here? And I think the reason is because they're in this face-to-face configuration. And so in the face-to-face configuration, vision works very well. But in other configurations, say the chimpanzees where it's front to back, the back person can't see the front person, or the Australopithecines who are walking side by side, you can't see the people. So I think when you have this face-to-face situation, I think so haptic cues are most important when you can't see your partner. And in this particular situation where they're face-to-face, you do see your partner, and I think that the haptic becomes somewhat a duplication with vision and vice versa. Okay, so I'm actually going to be done early. This is kind of my summary. So there'll be time for questions. So the standard model, which is kind of the cockatoo dancing animal model, the music first model, is essentially an asocial model that focuses on individual sensory motor, audio motor, entrainment skills. It only really focuses on one sensory modality. It's based on cues for entrainment that are external to the organisms, the people doing the entrainment. I say here there's no particular effector specified. My replacement model is the group dancing model for the origins of entrainment. It places the ecology exactly where you want it to be. It's interpersonal. It focuses on the group from its inception. So it's an interpersonal model. It's not this asocial, individual sensory motor model. It's very much a group model, which kind of reflects what's happening in human cultures. I think it has the benefit of offering three kinds of sensory cues, at least three kinds of sensory cues for entrainment compared to sound only. It's based on mutual interaction. And at least from my way of thinking, it's very much a bipedal locomotor model. And so I mentioned the paradox of the cockatoo, that it has a spectacular ability to entrain to an external beat, but there's really no evidence that there's this beat generator, this timekeeper in the wild. And so I think the group dancing model really solved this paradox by saying that the entrainment signal and the entrainment behavior are one and the same. To me, this is a big theoretical advance because I feel like with the dancing animal model, there's so many questions about who's generating the beat in the wild. And this kind of mutual entrainment with body percussion, I think really solves the issue. Like I said here, the entrainment signal, the entrainment behavior are exactly the same behavior. You only need one evolution. You don't need two separate evolutions. So then again, more speculatively, I place the origin of entrainment in dance, not music. And so where does music get its rhythm? I say it gets it from dance. And so I think about, in my thinking, that coursing was initially asynchronous. It became synchronous later. And so I've proposed, theoretically, I mean, that music co-opted dance's rhythmic system. This is pretty much the opposite to the way people think about that. Music came first, provided a beat, provided the groove, and then dance came secondarily. I'm reversing the evolution here that the ability to entrain came from group dancing, and that music via coursing inherited or co-opted this system from dance. And again, I want to bring this full circle to models of human evolution, human cultural evolution. And I think this interfaces a little bit with Konstantina, what she's working on, that we have not one, but two systems for imitative learning. We have the system of vocal imitation involving the voice that's related to music and pitch, speech, and the like. But we have the second full-fledged system for imitation that's based on gesture, that's based on the body, the visual, which I think is really the connection with dance more than is vocal imitation and vocal learning. And then more ultimately, I think this all is derived from the evolution of bipedalism. Bipedalism has had massive changes throughout our entire body and changes in our brain as well. And so in terms of this particular talk, we see sort of two big categories of changes to our vocal tract, changes to the way we move and stand. And so these could reasonably be the basis for not just speech, but for the musical pitch system, scaling, and the like. This one would be the basis for dance rhythm. And then again, I propose that musical rhythm is really an offshoot, that music has somehow acquired the entrainment system that evolved through a group dancing mechanism. And then to bring this full circle back to 2020, everything I've talked about today represents really just one of our two major systems for creating social bridges, group cohesion. This is the one that's based on synchronizing our movements, synchronizing our parts with others. But we also have this other system that's based on a very different principle about turn taking and alternation of parts and non-metric rhythms. This one becomes much more associated with linguistic and speech-based communication. This one, I think, maintains its role, kind of its original role as far as group cohesion, group rituals. This one, not always, but tends to become something much more dyadic. Whereas the other one stays much more at the level of, let's see, flash mobs with tens of thousands of people synchronizing. So it's two very different systems. We have to have a social bridges, I think, about the conversational interaction. Maybe it's happened before, I'm not aware of it, but if not, we should do one about conversation. That's it. That's my website, neuroarts.org. And thanks. Thank you. I think I'm gonna stop sharing just so I can see you guys.
We wished you were here so that we could hug you.
I know. Actually, I had a very surreal moment. I just got to tell you because I think you're using an owl, right?
We are.
I'll just say very briefly that when I first tuned into YouTube yesterday, I saw this and I saw Asaf, and I just thought he's in Paris, and then I saw you and I thought you're in Dresden, and it took me several minutes to figure out that you were in the same room. And it was very surreal that, I thought you were in, two separate images. And then I realized, oh my God, there are actually people in the room. Because I'm used to you being this virtual host. And I didn't know there were going to be live people. So I had this the other side, the surreal thing was that we had a solar eclipse yesterday, which kind of blew my mind. But the first surreal thing was seeing Asaf and you in this owl. I'm thinking that you're in different countries and then realizing, oh my God, they're in the same room.
We're a solar eclipse, Asaf, you and I. That's what we are. I love that. But no, I want to say thank you so much, and for remembering that I used to do this as a solo juggling act.
Oh yeah, no, you're definitely a dynamo. So
solar eclipse. I'm loving all of the praise go. No, we probably have more questions than there are minutes in the day. But I would like to first of all say thank you, if I don't, for just yeah, there are no words. You're amazing. Who has questions? Because I have 600 billion. Go. Peter, go.
Thank you for the talk. That was really cool. And I'm definitely convinced that music didn't create dance. And so I'm out of that cause. I was just listening to you. I was just thinking, so maybe this is two comments that is also a question. I was just thinking that of course you can dance without synchronizing with each other. And of course you can synchronize without it being rhythmic. let's say you move slowly like this, but still at the same time. And it seemed to me that rhythm really makes the synchronization much easier, though, even if it's not an external one, because when there's with rhythm, I know when to move at the next time, I can predict it or something. Maybe that's the case, maybe not. So, but the question was, why on earth would we have rhythms? And if it is in order to make synchronization easier, why on earth would we have synchronization? Is it like, what do these two chimpanzees gain from walking in a flock together? Does it make some practical things in the life easier? Or is it very good question? And the other tiny question, I guess there are rhythms in our hearts and our brains and our lungs far before we ever entrain to anybody else. So does that fit in this picture as well?
Yeah, I mean, so there are a lot of terms, there's a lot of terminology in this field, but when you talk about rhythms, meaning regular, sort of like isochronous rhythms, yes, they're found everywhere, and they're found throughout the animal kingdom. So you talk about physiological rhythms, locomotor rhythms, birds, whatever, it's a regular rhythm at the individual level, but there's not the same kind of interpersonal synchronization. So I'm talking about entrainment. I'm not just talking about rhythm here, I'm talking about rhythmic entrainment. So I want to make that distinction that rhythms are quite ubiquitous, but rhythmic entrainment is relatively rare. I mean, for a long time, people said it was only humans, but then you find these examples of these animals, like cockatoos, that are able to entrain to a regular beat. But then the question becomes, well, where's that evidence? Who's generating that beat in the wild? We don't know. Maybe there is evidence of that, but it's not known at the present time. So I do want to distinguish rhythms from rhythmic entrainment. And so rhythms are ubiquitous, but our capacity to do what we do with dance is relatively unique in the animal world. The question, I think, my answer is that of the social bridges, that the reason why we do it is to form social bonds, to make groups stronger. That's why I was trying to ground this in the evolution of culture, because that's really what this is all about. So it's not just about, I think, individual display, but about groups coming together. Like I mentioned this whole idea about using entrainment as a way to homogenize and make us more similar, and hence make us more different than this competing tribe, because those are the theories about the evolution of cooperation, that these group differences are really key for how we evolve the capacity to help one another and cooperate. So anyways, that's kind of my take on your question. There's rhythm is widespread. Rhythmic entrainment is very uncommon. Humans do it really well, and I think it's ultimately about forming social bonds and homogenizing behavior.
Keep asking.
No, Asaf.
Hi, Asaf.
So I'm actually in Paris. It's not. So I have it's just to get the story. Can we see your slide the results again with the possible?
The salsa dances.
Yeah. The one slide towards the end with the
various poses. Yeah, external.
Oh, yeah, okay, wait 1 second. Where's my slide? Oh, I'm still sharing. That's why. Okay, let me go back to. Let me just find it. There's that. There's this one.
You're not sharing, so do share, please. You stopped sharing.
Okay, wait, stop. Share. Okay,
Thank
can you see it now?
Yes.
Okay, so they're there. Okay,
Yeah. So my question is just about the no audio condition, which does seem to be lower than the other.
Yeah, it's significant. Yeah, that one's significant. Yeah.
And so in the story, and I'm probably not, it's too quick to get a wrap around your evolutionary story, but it seems that it suggests that still that there is a need for an audio, or at least audio post-gestural, whatever movement loop is useful and maybe even critical. I mean, how much we want to read that in this story. So I mean, one thing is talk about music, the other thing is to talk about audio to movement entrainment. And I think, and I mean, I'm not sure against who are you arguing against, the whole thing that audio is in any way relevant to primary, or specifically this social construct we call music. And those are, and at least your data suggests that the audio part is relevant, that once you don't get it, you don't do as well.
Yeah, is that a question, or is that just a
question? What are you arguing against, the audio part, or not against music? I mean, just to understand.
No. I think if anything, I'm trying to replace music with body percussion. So I think I spent most of the talk at the end talking about body percussions. No, I think the audio is very important, but I think like again, the other scenario is that music came first, that music provided this beat, that there were musicians that provided the beat, and then dance came secondarily. This is trying to ground group dancing in mutual cues. So I think, no, I think the body percussion is really central. This experiment points to that as well. But I also think that, for this particular experiment, there's some kind of redundancy here because of the face-to-face configuration. And I do a lot of folk dancing where I'm dancing side to side with people in a ring. And the people that I have the most haptic contact with, I have the least visual contact. So the people on my side, I can barely see. I'm looking at the other end of the circle. So I think in this particular experiment, because the people were side to side, it's made the haptic and the visual a little bit of a duplication. So maybe that's one factor here. But no, I spent all this time talking about, beating for beating, whatever, because I think that the acoustic cues are really critical, but I think they come from mutually generated sound, not from some external, some drum beat or some person in the distance or, people. So no, I think all the cues are important, especially, audio. But I think we have to think about body percussion as being the source of that sound. So mutually generated sound, the sound that comes from movement, as opposed to the sound that's external, which is what the music model is about.
So
I'm gonna
may
stop
I
trying
ask
to
a
see if I can
question?
see you. I want to
So
see you guys.
I have a quick question, because I'm a singer, so my own body is my instrument. So I wanted to ask you whether you think that there's room in your view for an individualistic scaffold onto which the group gets placed, where my body makes sounds which make me move in what might look like dance, so it's still interactive. It's my body with the sounds it makes in contact with the ground, or my two hands clapping. So there's still resonance with something. It might be my own body or with the environment, but which still promotes and provides the rhythm that allows me to then continue moving. It doesn't have to be another social agent, but that by having other social agents, it gives us greater space in which to create. And I would also like to push that it goes beyond synchrony. It allows us to create more complex structures, and that's in that really nice other evolutionary paper, and that's not Patel, but I can't have the name in my head, but Psyche Louis on it as well, and Patrick Savage one, I think. So yeah, is there space in your theory for an individual first and then a group?
Well, of course, all the capacities are individual level at some point, right? We're talking about individuals coordinating. So you have to have the individual capacity to coordinate in order for the group. I think that goes without saying that the individuals have the capacities. I'm not sure I get exactly your question. I want to point out too that
you're situated as an interpersonal account, which made a statement of it being a necessary condition to have another individual creating sounds.
Oh, I see.
The combination of the sounds that you entrain to, rather than a single body making sounds.
No, but I've talked about three kinds of cues. So there are visual cues and there are haptic cues. So I think it's some combination of the three. I don't think I have to talk about it. There's just one kind of cue. Maybe that was what Asaf was asking me as well, whether I prioritize the audio. But I think that this model allows for three kinds of sensory cues to interact in some way. Maybe there's going to be sound that just kind of like if you're stomping, there's going to be sound coming from your stomping. Like I mentioned the haka from New Zealand because they grunt. And so you don't have to be singing in your kind of singing. It just like whatever could be a kind of body percussion that comes through the vocal track. It doesn't have to be sort of the sing-song kind of musical thing. But I just want to mention in relation to your question, you're probably a classical singer, I suspect. So classical singers tend to be quite immobile on stage, but look at sort of like a Madonna or Michael Jackson who dance while they sing. They're doing sort of both functions, and they have backup dancers. So they're doing group dancing while they're doing sort of group singing. So they're kind of doing everything. I think a typical, like a leader singer doesn't do much in terms of dance-like movements, and they're usually soloists as well. So but there's kind of a spectrum of to what extent singers dance, and some are full-fledged dancers like the Madonna types who are doing fully choreographed routines while they're singing. So I think there's also a spectrum of how singing and dancing interact at the social level. But no, I think the model says that there are minimally three kinds of sensory cues that could be used. It could be all visual, things that have been talked about throughout this conference, the different kinds of cues that are used for integration and synchronization.
I have so much to say about touch, but I do want to check if there are other questions. See, I'm lucky they're not putting their hands up. They're too
Yeah,
scared of me.
yeah.
But so we work on touch here, obviously in Dresden now, and I have a theory, and you can maybe shoot it down. But the idea is that touch becomes relevant not only when you have absent visual audio cues, which are very reliable in the temporal domain, but also when you lose contact or when you need to provide a highly salient piece of information. And that's why with Tango, I think you have that. Okay, there maybe you are also losing some visual contact, but touch is extremely powerful, maybe only in sort of acute moments. But I think that there's something about the quality of what touch provides, which is different. It's not redundant. So I do think that there's redundancy across the modalities, but it's also maybe useful to think about what's special, right, about what the various modalities are giving. So that's more of a comment. But if you have any thoughts about what
when I gave the example of the blues dancing, I mean, even we were talking among ourselves about these kind of micro movements, and I think people like Asaf who do contact improvisation know all about micro movements. And I'm not one of those people, but I do sort of traditional, couple dancing. But these micro movements, especially when you can't see your partner, you become, as you know, very aware of their physicality and how they're shifting their core. So I think there's all this kind of micro leading and following that occurs in dances with body contact that, obviously don't occur when there's not the contact, but become especially salient when you're close enough with a person that you cannot really see what they're doing. So by the way, I was going to mention also that when I was leading these dances in which couldn't see my partner, I was still quite visually aware because I don't want to walk into the walls. I don't want to, bring us to the walls. And I'm also looking at other couples to see what they're doing because I want to imitate what they're, I want to get some inspiration from other couples. So I'm using my visual simulation, not so much for my partner, but actually to think about my leading and what I can, in a very non-creative way, how I can imitate the other people in the room. So my visual system was very active, but it wasn't focused on my partner because I couldn't see my partner. So that was more the haptic. But I was using my visual cues to think about what the hell I should do in leading.
So I think, because in the interest of time, we want to make sure we don't overrun. I want to thank you so sincerely for joining us again on Social Bridges. But I also hope that one day you'll come and be with us in person because it would just be the best.
Like I said, I'm now officially the oldest person in this field, so I feel like I'm the elder.
On dialogue for you. I set it up for you. I want to thank everybody.